Now that you know about the theory of plate tectonics, let's actually describe some of these boundaries. Divergent boundaries move apart from one another. Convergent boundaries is where plates crash together. And a transform boundary describes a boundary where the plates slide past one another. We have already discussed divergent plate boundaries in the Theory of Plate Tectonics lecture. You can find it in this module. As you know, they have volcanism, very shallow earthquakes, they make a mountain, and they create new crust. Now, not every coast has a plate boundary. If you go to the East Coast, for example, what you'll find is a big, let's say you're on land here, a really gentle slope and a big shelf, and the water just gets deeper and deeper and deeper. By the way, these terms here and this cross-sectional diagram might be useful in some of your labs. Notice that a passive continental margin has no earthquakes, volcanoes, and it's not really making new mountains. Another feature of a passive margin, once again, we don't have these on the West Coast, this is an East Coast phenomenon, is a lot of mud flows downhill underwater, and sometimes that mud is preserved. A turbidity current can move over 60 miles per hour. It's an underwater landslide. What about the boundaries where things crash together? A convergent boundary. Well, as you know, there are only two types of lithosphere. We have oceanic lithosphere and continental lithosphere. If we crash these two types together, sometimes we'll have an ocean-ocean boundary, or a continental-continental boundary, or a mix of the two. You may know these zones as subduction zones. In an ocean-ocean boundary, and I'll show you a picture in a moment, we have an area of earthquakes, we have volcanic islands, we have some really old plates that are forming. Here's a picture of some islands that form above a subduction zone. This plate is crashing into this plate along this line. Here we have this older plate subducting under this plate. The earthquakes here can be deep or shallow. If you want to visit a place like this, you could visit the nation of Japan or the Philippines. But what about when oceanic crust crashes into a continent? Does it still make islands? It does not. It creates something called a magmatic arc. Let's look at a picture. Here is an oceanic plate subducting under a continental plate. It happens to be South America. Instead of making volcanic islands, it actually creates the Andes, a huge mountain range that has active volcanoes in it. This earthquake zone, also called a Benioff zone, actually has earthquakes that are deep and shallow and very dangerous. There is also a deep trench. Now, this provides a place for very cold, nutrient-rich water, and that means places with this type of subduction zone have a really good fishing economy. Fish love cold, nutrient-rich water. The earthquake zone, also called Benioff zone or Benioff-Wadati zone, is basically the face of the subducting plate. And anywhere a plate moves, we call that movement an earthquake. Mostly they happen on plate boundaries. But what if I crash two continents together? Continental crust doesn't sink. We will not get a subduction zone. What we get instead is a mountain. Here is a place where crustal rock is crashing into crustal rock, the classic example being the Himalayas, the biggest mountain range that Earth has perhaps ever known. We do not have volcanoes in the Himalayas. We do have earthquakes and beautiful scenery.